Hi everyone, I hope I find you well. Someone did post on the group saying you need to understand how to come into conclusion when you're proving by induction. So I'm going to work out that same problem and try to come up with a solution. How do we conclude and how do we communicate to the marker when dealing with induction? So the question was asking us to prove by induction that given 0 less or equal to a less than b, a to the power of n is less than b to the power of n, where n is an element of positive integers. Okay, cool. That's the given statement. That's the given problem to be proved. Okay, all right. So now we start by saying so this is our solution. Let Pn be the statement that a to the power of n is less than b to the power of n. In other words, we are rephrasing the given statement. Okay. So that's our Pn, and also that condition still holds for all, we can say, for all n element of, okay, we are only taking positive integers. Okay. So proof by induction consists of steps. So this second dot here is for the first step. Okay. Some markers may want to award due marks for that. But the first necessary step is called the testing step. You need to test, okay, to test whether the statement is true. So P1, you can see that P1 is true. Since a to the power of 1 is less than b to the power of 1, we substitute where there's an n, we put a 1. Where there's an n, we put a 1. Where there's an n, we put a 1 and 1. So this is true. Okay. So which is true according to that statement. So P1, the testing step passes. Okay. So we now say these dots are necessary. Okay. These dots here are unnecessary because your marker can easily follow without these dots and see that these are the steps. Okay. I'm doing this for the purpose of you guys so that you can clearly see the necessary steps. Okay. We assuming that this is also true for some k element of positive integers. Okay, that is, this is a shorthand for that is pk is such that a to the power of k is less than b to the power of k. This is what we call the assumption step. Okay, for all k. Okay, yeah, for all k. Okay, all right, or where k is an element of that. This is positive. Okay, so we say, assume that it is also true. Then we need to prove that it is also true for k plus 1. That is pk plus 1 is such that a to the power of k plus 1, we are replacing where there is an n, we put k plus 1. So a to the power of k plus 1 is less than b to the power of k plus 1. So we need to prove this. If we can prove this, then it means the given formula works for all n element of that. So here is the proof, which is another necessary step as well. Okay. So how do we prove? We start off from the left hand side and try to achieve the right hand side. If we can get to the right hand side, then we would have proved that the statement is true. So we start by saying a to the power of k plus 1 is equal to, you can clearly see that this is by laws of indices. A to the power of k plus 1 is just that. So now we make use of what we had earlier on. Look at P1. We said for P1, okay, whichever, you can start to deal with this or that. What we want is at the end, we want to achieve that. Okay, so I can always start by maybe using P1 or PK, but okay, let me not confuse you guys. Let's start off with PK. Look at the assumption step. It's saying a to the k is always less than b to the k. So let's have, where there's a to the k, I'm going to write b to the k. Let's replace that and put a to the power of 1. Which inequality, guys, do you think is going to come in here? If a to the k is always less than b to the k, by our assumption, if I replace that by that, which inequality should come here? Is this bigger than that, or vice versa? Yes, you are correct. This quantity is greater than that, because this guy is less than that. This is just maintained. We have maintained it to the 1. Okay. So also, guys, tell me, what do you think about a to the power of 1 and b to the power of 1? If I write b to the k times, instead of a to the power of 1, and I write b to the power of 1, which inequality should come here? What do you think? Which inequality should come here? Yes, you are right. It's this one. Because b to the power of 1 is always less than that by p1. Okay? So, but this one is none other than b to the k plus 1 by the laws of indices. So, you can clearly see that you can connect from here all the way to that far end. Ignore the middle steps, okay? So, you can say, therefore, a to the k plus 1, this, I take that last inequality, is less than b to the k plus 1. Okay? Hence, proved. We wanted to prove, Mus. We wanted to prove. Hence, proved. So, we conclude. Given 0 less or equal to a less than b, a to the power of n is always less than b to the power of n for all any element of positive integers. Okay. We are done. I hope this helps. Hope it works. Wish you the best, guys, and stay safe. Sharp.